In this video, we will talk about how to find all values of k for which some augmented matrix is a consistent system. So I have three examples for us to work through here. Let's check out the first one. Let's say we have the following augmented matrix with these values. For what values of k would this augmented matrix be a consistent system? So the first step to solving this is we first want to get this matrix in row echelon form, because that's how we can solve a system of equations. So recall that in row echelon form, the first pivot entry in the first row, every value below it must be 0. So notice we want to get the 6 to be a 0. So how could we do that? Well, notice that if we take this 6 and we subtract 6 times the first row, or in other words, 6 times 1, we would get 0. So let's do that. So let's say row 2, the values in row 2 are going to become the original value in row 2 minus 6 times the value of row 1. So if we do that, here's what we get. The first row doesn't change at all. 1k and 4. In the second row, we get row 2, so the value in row 2, so 6 minus 6 times 1, that's 0. So this becomes a 0. This next value is 12 minus 6 times k. So we're just going to write 12 minus 6 times k. And the last value will be 16 minus 6 times 4. So 6 times 4 is 24, so 16 minus 24 is negative 8. Now, once we have the matrix in row echelon form like this, we can imagine that this first column represented the coefficients for some variable, we'll just call it x1, and this second column represented the coefficients for another variable, we'll call it x2. We could write these two equations like this: x1 plus k times x2 is equal to 4. And the second equation would be 0 times x1, so we don't even have to write that, plus 12 minus 6k times x2, so we get 12 minus 6k times x2 is equal to negative 8. So notice that if we can solve for x2 in this second equation, then we can plug that into x2 right here and figure out what x1 is. So is there any way that we would not be able to solve for x2 right here? Well, notice that if these parentheses, if this value was equal to 0, then 0 times anything would be equal to 0, which can never be equal to negative 8. So as long as these parentheses don't equal 0, we can solve for x2. So let's figure out for what value of k would actually make these parentheses equal to 0. Well, we can say 12 minus 6k is equal to 0, and we'll solve for k. So if we add a 6k to each side, we get 12 is equal to 6k. If we divide both sides by 6, we get k is equal to 12 divided by 6 is 2. So this is the value that would make this parentheses equal to 0, which would in turn make this entire equation inconsistent or not possible. So we would say as long as k is not equal to 2, all other values of k would make this augmented matrix a consistent system. All right, let's try another example. Let's say we have the following augmented matrix. For what values of k would make this augmented matrix a consistent system? So once again, we first want to convert this matrix into row echelon form. So here's our first pivot entry. We want all values below it, in other words, just this negative 4, to be a 0. So how could we make this negative 4 equal to 0? Well, notice that we could do negative 4 plus 4 times row 1, because that would be negative 4 plus 4, which would be 0. So let's do that. So let's say the new row 2 is going to become the original row 2 value plus 4 times the row 1 value. So if we do that, let's see what we get. The first row doesn't change at all. Negative 3. And the second row will become negative 4 plus 4 times 1 is 0. And then we have 8 plus 4 times k. So let's write 8 plus 4 times k. And this last value would be 12 plus 4 times negative 3. So 4 times negative 3 is negative 12. So we have 12 minus 12, which is 0. So once again, if we imagine that this first column is the coefficients for some variable, we'll call it x1, and this second column is just the coefficients for a variable, let's call it x2, then we could rewrite these as x1 plus k times x2 is equal to negative 3. And the second equation we could write as 0 times x1, so we don't even have to write that, plus 8 plus 4k times x2. So let's write 8 plus 4k times x2 is equal to 0. So if we can figure out what x2 is here, we can plug that into the first equation and solve for x1. So we just need to ask ourselves, are there any values for k that would make this left-hand side not able to be equal to 0? Well, notice that if these parentheses were equal to 0, then 0 times x2 would be 0, so that's good. And notice that if this was anything except 0, we could simply make x2 equal to 0 to make the left-hand side equal to 0. So for example, if k was 1, that'd be 1 times 4 plus 8, that's 12. We would have 12 times x2 is equal to 0. We could just let x2 be equal to 0, and this would be solvable. So no matter what value that we have for k, it's always going to be possible for this left-hand side to be equal to 0. So for this example, we would say all values of k would make this augmented matrix a consistent system. All right, let's try one more example. Let's say we have the following augmented matrix. Let's figure out for what values of k would make this a consistent system. So once again, we're going to try to figure out how can we convert this matrix to row echelon form. So if this is our pivot entry, we want all values below it to be equal to 0. So how can we get this 4 to be equal to 0? Well, notice that if we take this value in row 2 and we subtract 2 times the value in row 1, we would get 4 minus 4, which is 0. So let's do that. So we'll say the new values of row 2 are simply going to be the original values of row 2 minus 2 times the value in row 1. So if we do that, here's what we get. First row doesn't change. The second row, we have 4 minus 2 times 2. That's 0. Here we have negative 6 minus 2 times negative 3. So 2 times negative 3 is a negative 6. So negative 6 minus negative 6 is the same as negative 6 plus 6. So we get a 0. And here we get 7 minus 2 times k. So 7 minus 2 times k. So if the first column just represents the coefficients for some variable x1, and the second column is some coefficients for a variable x2, we can write these as 2 times x1 minus 3 times x2 is equal to k. And the second equation would be 0 times x1 minus 0 plus 0 times x2 is equal to 7 minus 2k. So notice that the left-hand side of this equation is going to be equal to 0, because 0 times something plus 0 times something else is always just going to be 0. So if this left-hand side has to be equal to 0, what is the value for k that we would need to use to make sure that the right-hand side is also equal to 0? Well, we can solve for k by saying let's just add a 2k to each side. So 2k is equal to 7. If we divide by 2, we find that k must be equal to 7 halves, because that's the only value for k that would make this right-hand side equal to 0, and thus the only value that would make this second equation consistent, or make it a true statement. So we'll say k is equal to 7 halves. This is the only value that k is allowed to be if we assume that this augmented matrix is a consistent system.